Woohoo! Welcome back. Today we're going to be sketching the graph of a polynomial function. Woohoo! And we've got our friend Sharktopus, who is both smooth and continuous, to help us out. And I'm going to start out with the function p of x equals x cubed minus 2x squared minus 5x plus 6. To save time, because the factoring would take some time, I have written it out in its factored form. It is x cubed, so it's a third degree polynomial, which means we are expecting 3 factors, which we found, or I found. And again, as I've been saying, if you're struggling with factoring, either hold on because the rest of chapter 3 is going to be working on exactly this topic, or pause the video and go look at the factoring we've done in class, talk to a tutor, find me, let us help you out, okay? But hopefully then I'm saying welcome back. And as you can see, this polynomial factors as this. And if all you want to do is say, you could go ahead and multiply these 3 out using FOIL and then multiplying by the third. And confirm that it equals that polynomial. That's also a great thing to do. But if we've got a polynomial and we factor it, what are the steps to graphing? So, step 1, find the zeros. My gosh, we do love setting things equal to 0. So we want to know what happens when p of x, which is x plus 2, x minus 1, x minus 3 is set equal to 0. And the answer is the 0 property tells us that x plus 2 equals 0, or x minus 1 equals 0, or x minus 3 equals 0. And again, remember, we've got this lovely connection. If it's a third degree polynomial, x cubed, then there are going to be 3 factors, and there will be 3 zeros. Now, it is possible that 2 of the zeros match. And then remember, we talk about multiplicity. So if 2 matched, then that 0 would have multiplicity 2. But in this case, they are going to be 3 different values. And remember that in this last video, we talked about the formal way that we write this. And the formal way we write it is x minus c, which is a reminder that if you start with x plus 2, your 0 is minus 2. If you start with x minus 1, your 0 is plus 1, right? So it's an opposite sort of situation. Okay, so very quickly, and you don't even necessarily need to do this work. You could just read off -2, +1, +3. We get our zeros. Now, what are we going to do next? Well, if we've got all the zeros, which we do believe we have, right? This is a third degree polynomial. This is cubic. And so I've got 3 zeros. That's all I'm expecting. So there should not be any other zeros. So I'm going to go ahead and set up a number line. And I'm going to put them in order. So there's -2, 1, and 3. And then I've got my 3 factors, x plus 2, x minus 1, and x minus 3. I'm going to set up a chart to see what the behavior of each one looks like. So for example, x minus 2 is 0 at -2. And then what we could do is we could say, well, what is it at all these other values? So let me start with the test value. My test value here, you can pick anything that's to the left of -2. I'm just going with -3. Between -2 and 0, I could pick 0. I could pick -1. Lots of options. You could pick 0.625 if you wanted. Between 1 and 3, I'm going to pick 2. I like to pick integers. It makes it easier for me. But if that's too boring and you want to pick a number like 1.283, go for it. And then over here, I'm going to pick the number 4. So again, my test value's very straightforward, possibly a little boring. So spice it up as much as you'd like. So if x is -3, -3 plus 2 is negative. 0 plus 2 is positive. 1 plus 2 is positive. 2 plus 2 is positive. 3 plus 2 is positive. 4 plus 2 is positive. Okay, x minus 1 is 0 at 1. Negative 3 minus 1 is negative. Negative 2 minus 1 is negative. 0 minus 1, negative. We kind of see what the pattern's going to be, right? You can pretty much then say, oh, these are going to be plus, plus, plus. But let's double check. 2 minus 1 is 1. That's positive. 3 minus 1 is 2. That's positive. 4 minus 1 is 3. Positive. Okay, one more. X minus 3 is 0 at 3. Negative 3 minus 3, negative 6. Negative 2 minus 3, negative 5. 0 minus 3, negative 3. 1 minus 3, negative 2. 2 minus 3, negative 1. And then 4 minus 3 is positive 1. So I get a plus there. Okay. So for the whole polynomial, if I've got a negative times a negative times a negative, 3 negatives, that's going to be negative. 0 times anything is 0. And positive, negative, negative, it's going to be positive. This will be 0. This will be negative. This will be 0. And this will be positive. So we can kind of see, right, that if it's negative here and then 0 and then positive and then 0 and then negative and positive and 0, we can kind of see if we're going to sketch out our graph, it's going to be there, it's going to be there, it's going to be there, right? If this is the x-axis. And then it's negative, so it's going to be down here. It's going to come up and be positive. Then it's going to go down and be negative. And then it's going to be positive there. So we've got, because the whole 3 negatives mean this is negative over on this side, it hits 0. It's positive right there. It hits 0. It's negative right there. Hits 0, and it's positive. So that gives us a sketch of what we think the graph's going to look like. So that's the first step, is we found the zeros. And so we found the zeros, and then we set up a chart to see what the behavior is going to be. Okay. And sometimes when we go through all these steps, people are like, do I have to do all the steps? And I would say, well, if you're taking a test and the test asks for all the steps, you do it. But if you're just graphing for a homework assignment, I mean, I would practice all the steps so you're familiar with them, but they aren't necessarily all equally useful depending on which polynomial you're looking at. So, okay, P of x equals, where did it go? Let me write it down. X cubed minus 2x squared minus 5x plus 6. Okay, remember to check the end behaviors. We look at the leading term. So we say x cubed. As x gets very, very large, so as it gets large without bounds, so as we're going to the right, x cubed, a very large number cubed, gets very large. So we're expecting something that goes like that at one end. And then as x goes very negative, so as we're going to the left, this is negative numbers cubed. Negative numbers cubed stay negative, so we have something that looks like that. So overall, our graph is going to look, we don't know in the middle, but it'll go up at the right side and down on the left side, right? So that's kind of the shape we're expecting. Now, let's go back to what we have on the front page. Is this what we got here? And the answer is yes. Here's the detail in the middle. We know we were expecting it would go off to the right and go down to the left, and that's what we're expecting. So these two steps just confirm one another. And sometimes we do that. In fact, a lot of times we do that in math, that we redo different steps so we have internal checks. It's good to make sure that what we're guessing is correct. If we ended up with two different pictures, then we should go back and double check because one of them would be off. Okay, table of values. This one is hard. And it's not hard because it's hard to do, although it can be kind of annoying, but it's hard to know how many points you should use. So there's a hint. You may use test points, but you don't have to. I honestly think it can be really helpful to just go ahead and use all the test points. Polynomials sometimes do some weird stuff. Just because they're smooth and continuous doesn't mean they don't have like little hiccups. Now, we're going to be able to graph those better once you are in calculus. So for right now, we're just sketching. We're doing our best because we don't always know. But it can't hurt to do more points. The problem with that is if you're going to plot 100 points, it's going to take a lot of time, and maybe you don't need to do that. So I would say, again, I would go and look at all of your test points. And if you actually wrote down what the values were, then this gets a lot easier. I just put the pluses or minuses, so I'm going to have to do all the work here. That is okay for me. So x, p of x. So my values, -3, -2, 0, 1, 2, 3, and 4. Okay, so this is a job for calculator. Now, this is one of those moments which, if you have a graphing calculator, you'll be able to do, you can actually set up a chart in your graphing calculator and quickly finish these all up. For me, I'm just going to have to do some calculations, right? So I've got, okay, -3, and then I'm going to cube it, -27 minus 2 times, and then I happen to know -3 squared is 9, and then plus 15, because -5 times x, plus 6. So I get a -24. Now, the other way you can do this, which some people think it's easier and some people think it's harder, if you have the factored form, so what was that? It's x plus 2, x minus 1, x minus 3. So instead of plugging it in like this and having to use your calculator, you could do -3 plus 2. -3 plus 2 is -1 times -3 minus 1 is -4, and -3 minus 3 is -6. So -1 times -4 is 4 times -6 is -24. Does that make sense? So you can actually plug it into the multiplied out version or the factored version. I think the factored version personally is easier, but you can do either way. Now, I happen to know that at -2, I get 0. At 1, I get 0. And at 3, I get 0. So I don't have to worry about those. 0, I'm going to use this form. 0 cubed minus 2x, 0, 2, 0 squared minus 5 times 0. All this will be 0, and all I'll get is 6. Or you can try it out here. 0 plus 2 is 2. 0 minus 1 is -1. 0 minus 3 is -3. And you get 6. When x is 2, you can plug this in. This will be 8. Minus 8 minus 10 plus 6 is -4, or 4. And then 2 minus 1 is 1, and 2 minus 3 is -1, so you get -4. And then for 4, oh my gosh, it's going to be something hideous. Or 4 plus 2 is 6, 4 minus 1 is 3, 4 minus 3 is 1, and I get 18. So those are my values. Now, I can already tell that some of these values are going to be hard to graph, right? Specifically the end endpoints at -3 and 4 so far. They're not the actual endpoints. But as I go in to graph these, I want to be thoughtful about what space I have. And I've got a pretty good big graph. But honestly, I am not prepared to graph -24 or 18 unless I start changing the scale. So I'm going to focus on these points and then do my best to kind of get the idea from these, if that makes sense. Okay, so I'm going to put my y-axis and my x-axis right in the middle. If you cannot draw a graph that's at least as straight as I'm drawing, and it's not very straight, then you should definitely be using a ruler. Okay, so let's see. This is 1, 2, 3, 4. At 1, I'm at 0. And at 3, I'm at 0. And here's -1, -2. I'm at 0. And there's -3. -1, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I've got the point 0.06 right there. There's our 0.6. I've got 2, -4, -1, -2, -3, -4. Keep in mind you don't have to draw in all of the values on the axes. Make sure you've got at least one drawn in. This is 2, -4. And 4 is going to be 18. So 4 is going to be way up here. And at -3, it's at -24. So it's going to be way, you can't even see, but way down here. So I'm going to connect the dots that I have. A couple things that can be helpful when you're graphing. That one got a little, okay, not as helpful. But it's a sketch, so I'm not gonna stress it out too much. Some things that are helpful. Basically know that for most people, graphing by pulling down is easier than pushing up. So I always start at the high point and bring it down through the low point if I can help it. Now this one, there's not really a lot of option. You can see it gets a little wiggly there. Also try to do a smooth motion if you can. I tried to do it in 2 pieces and ended up with this weird leg that goes like that. So let me check everything I know. There are 3 zeros. I've got them right there, -2, 1, and 3. Excellent. I've got my behavior where it goes, it's negative, and then positive, and then negative, and then positive. Yep, good. Okay, next up, I have end behaviors. It goes up on the right, and it goes down on the left. Woohoo. And then I've got the points that I plotted. So how did we do? Well, the answer is, again, without calculus, we did massively amazing. Sorry, pardon me, Sharktopus. So it's such a big graph, I can't even fit it into the screen, but let me show you the different parts. It turns out that this does not stop at a maximum of 0.6. See how I went down? So what could I have done to know that it actually keeps going up? Well, what I could have done is I could have looked at what happens when x is -1. So when I look at this, right, I went -3, -2, and then right to 0. I probably should have looked at -1 there. Maybe should have considered it, because without that point, I didn't know that this actually keeps going up and then comes back down. So unfortunately, I missed that. And again, that's something that will get better with calculus. So what is the lesson from that? Well, I should probably check more values, at least check all of the integers. Okay, so that's something I could fix for the future. let's take a look. This is looking pretty good. Now I had it go down and come back up at 2, -4. Is that correct? And the answer is it's really close. The actual minimum, the local minimum right here, is at 2.12. Is there any way that we could have figured that out? And the answer is no. That is entirely something that we're going to have to leave for calculus, but we're pretty close. We actually got a pretty good sketch. So just using paper and pencil and maybe a calculator or maybe some tricks, we can actually come up with a pretty good sketch of the polynomial. And it turns out for what we need to do with it in math, that's going to be awesome. So rock on, understand that it will not be perfect. That like I missed that it should have gone up, but obviously, you know, I printed this out ahead of time, so I knew that was going to happen. I chose this, you know, as an example to say, hey, we can't anticipate that happening, but we can still get a pretty good graph. So keep that in mind as you're graphing and as you're working through this section. And congratulations, we're through the graphing section, which I think is the big beast of this chapter. You can let me know if you agree. So go ahead and take a break, you know, refresh yourself, get a nap, go do something fun, and then come back. And the rest of chapter 3, most of the rest of chapter 3 will be refining. How do we divide? How do we factor? What do we do to actually pull apart our polynomial so that we can get from this to this, because it's not always obvious or easy. So know that I think the world of you, and I think you're amazing and so smart and so patient. And I wish you only the best of luck and the best of life. And I will talk to you in our next video. Woohoo! Math on.